The Mr. Gun cipher. So what I want to do is explain how we can get from a seed word of 12 words or any length of words to a cipher. So what happens is that cipher will go through and the different parts of the seed words will be represented and scattered throughout the pulse chain in the form of NFTs. So there'll be an NFT contract, and the contract will have an ERC 1155, which can have many ERC 721 NFTs associated with it. So it will have the passphrase ones, and the passphrase will have this passphrase and the first ID associated in the metadata in the name and descriptions part of it. And in the name and description of the cipher text would be the next ID and the cipher. All of this will be decoded into the cipher and only available from the program itself. A little bit of text here is saying that I'm going to have two NFTs that would be sets that would be minted from the 1155. Both are minted on a regular basis. Say, for instance, once every 5 minutes is the idea. So, if you take the cipher, the software that is downloaded onto the PC will go and they'll split the cipher into 30 parts. Each part will be not randomly, each part will be split into each parts that decided by the code. And then the contract will mint the entities and wait for the next set. So as we go through the time that we leave the PC open for the user will decide, the parts are then created and created into the next set of NFTs that will go there. The kind of further apart they are, the more secure this will be. And then at the end, all of them are created into the NFT sets, and then the user has got them on the pulse chain. All the time, different PCs and different programs are writing information at the time. So this will get interspersed in between the different ones so that they got truly a large amount of data going through so that there's a sea of data that's out there that can go through. The algorithm and the contract will actually be creating stuff itself, so there'll be dummy data in there as well. So the idea and how is it done? So how do we get from the seed words to a cipher? So the cipher looking like this, which would be 240 characters. So first thing we're going to do is we have to split the cipher, split the seed words up. So we go and mix this list up, and we'll be putting these into different positions in a 30-word set. So there's my 12 words that have been put in there. So let's consider this. If we're going to split this up into there, we'll get this huge number here of times in all of these particular ways of getting together, and we end up with a number here, which is the different possibilities. So even if you were to see that list as it stood at the moment, when it hadn't been deciphered even further, you've truly got quite a job to do as a team. So we've got these teams and we've got fixtures in the teams, which we'll kind of go into a little bit later. We've got a passphrase that we talked about if you watch the other video of how that is set up, the month that will convert the lists. And then we use these in the seconds to create a unique number. And that unique number is 60 seconds times 60 minutes times 24 hours times 365. And then that, sorry, that is actually also times 10. I should have said that in there, which gives a number of, roughly speaking, 300,000 that we can split this into. So what we've got to do is take these 300,000 numbers to split them into actually get this to replicate this. So as I talked about before, each team has got JSON data that is associated with the teams that actually goes to individual teams. So in our example, we had Swindon Town because we looked at the magic roundabouts and the likes. these would be the dates of the particular fixtures of that particular team with a date of the individual game and also the opponents. So this is important later on. This is the name of the opponent, but basically we're taking this team so we can split that up. So let's have a look at this. What we'll be doing is we're going to split that data up so that it actually comes in a different manner. So what we're doing is we're going to take the uh, what we're going to do is get the logic for the data in the teams, and we're going to use the last two digits of the year in that particular one to actually go and set this up. So we've got an opponent. And we'll take that and make a number from the ASCII set, which is in the logic and the likes. So we're going to take a large number from position 1, and then we've mod that by the number of fixtures that particular team. So say it's 42, it could be all sorts of different ones. And say we get 10 from that. And then we go through the second time. We've got 41 this time because we've won less in terms of things. Say we're going to get 13. If we get 13, then we're going to skip 10 because it's already been used, and we put that in position 40. Going for C, we're going to put that into position 7 because of that. And then we get that complication coming on further down the lines that if we've got, say, 34 from 39, we're going to skip 7, 10, and 14, and that will give us position 37 onwards until we've finished the whole cipher. What ends up happening is that these dates are now going to be mixed up in terms of things. So we've got A here, which is the 15th of January. B is the 17th, 18th of September. And then that gives us a reasonable chance that we've actually mixed these teams up quite nicely. So we're going to use the code to pick each letter. So we've got the 30 teams and the positions of them are going to be worked out in the slide back worked out to the logic in the slide back to fixtures. That's going to be used quite a lot. So we've got the 15th of January in this particular case, the 8th April, which is the date that we kind of used last time. So basically that's the fourth month of the year. Fourth month of the year is going to be 8 to 10 in terms of using the 24-hour clock and the lights, 'cause it's 12 months. And then in between, then we're going to be using the passphrase data to come and get us a position between 1 and 7,200, which is the number of seconds in 1 hour. And then we're going to return the year from an algorithm that will be run over the ASCII characters of the opposing team and mod that by 10. So truly, we can have any particular number. So we could have quite easily the first second of the year in January the 1st, or we could have the last second in the year in December the 31st, or anything in between. It's not random. It's chosen by the passwords. You're going to have to know these passphrases and everything to break that if you're going to go through that side. So what ends up happening is as we saw before, we actually put the different characters in the different positions based on what came back from what's been described before. And then we're going to go and we're going to be using the BIP 39 set. I think I'd explained that in the other video. And then what is left over, we're going to go and use the passphrase to go and pick somewhere that's kind of in a different position. And then we'll create, from the words that haven't been used, a list of words that can be used to say that these are 1 to 24. In this particular instance, we've got 12 words. So we've got 12 words here. We add in the next part of what has been decided before, the word base there, that is in that position there. That will always be in that position in terms of the cipher. And then it can go and we fill the rest in with whatever we filled in. So we've got this letter that's been jumbled up, but there is a logic to be able to get that back. So in the alphabet here, we've got from here, we're going to be using 2 characters from this particular set that will have a random look about it, but it's produced by the actual algorithm, which we'll explain. So what we'd have is we'd have a pool of 2 set characters from here for each individual letters. This goes up between 63 to 114 characters. which means that we're never going to run out of letters and the likes for it. So even in the 24 word phrase is you're never going to be in a position where you are going to reuse any character whatsoever. So here's a demonstration of that. Is that because we've got percent and one in the B characters, we can go from there. We use H and G in this instance, and then for the E's, we're using the different E characters. So we never reuse anything in a particular step. This is bigger, obviously, but that's kind of the logic of how that is run. So how do we build the alphabets? So we've got the opponent's name from the alphabet, which is modded to pick up the pose size. This is from the team's data, and we're going to go through each individual one which has been created from there, and then we're just going to create create the numbers in the same sort of way. So basically, what we end up with is that to actually go and guess how this is all being shuffled up, you would actually have to go and you would have to do all this math before, and then we just got a number that I couldn't even. The calculator was starting to become unreadable at the time. We were well over 100 zeros at that time, and then you've got the character pairs which are added into the pools, and we've got a way of ensuring that there's no duplicates of the pairs of letters when we actually come to the end. That's the end of the presentation and a high level view of the logic that is in place. I believe that to actually go and hack this particular logic is going to be incredibly difficult. It's going to be easier to hack the actual passphrase, which, as I said before, is incredibly difficult in itself. I'm quite confident this is going to be secure. But there's a presentation. Thank you very much for listening.